Okay, so 7G.3, we have mean and standard deviation of a binomial distribution. So we'll just introduce you to some notation. Firstly, we're going to describe two ways a variable can be distributed. We have x as a random variable, and we have x is distributed according to now the letter here would dictate whether it's binomial or normal. So in chapter 8 and 9, we'll have an n there for normal. But yeah, we have binomially distributed, and then we have the number of successes and the probability of success. So if you think of the seed, the number of trials, probability of success. We were talking about a seed germinating before. We had 6 trials and a probability of 0.85 of germinating. So we could describe that distribution using this notation. That's what it means. It will pop up in practice tests for you to have a look at. We have here a number of properties: mean, standard deviation, and variance of them. Okay, example problems. The probability of a match being defective. So you light a match and it produces a flame. If it's defective, it means it doesn't work. Given there are 50 matches in a box, find the mean, standard deviation, and variance of the matches. So firstly, if we're going to describe this distribution, it's binomially distributed because the probability remains the same after each trial. We have 50 matches in a box, and the probability of it being defective is 0.03. All right, part A, find the mean, standard deviation, and variance of defective matches. So the mean is n times p. So in this circumstance, 50 times 0.03, which is 1.5. So on average, we expect 1.5 matches per box to be defective. For the standard deviation is the square root of n times p times q. So I'll do the variance first and then we'll just square root it. So 50 times 0.03 times 0.97. So 1.5 times 0.97. Get it quickly. And then square root it. We have 1.445, 1.455, 1.46. And then we know the standard deviation is the square root of the variance. So it's the square root of our answer here. And we can leave it like that or round it to 3 6 either's fine. So we've got there the mean, standard deviation, and the variance of x defective matches. Okay, here we go. Find the probability of the mean take sigma being less than x, being less than the mean plus sigma. Okay, now we're going to have to evaluate our standard deviation. Say again.
Why are you saying sigma?
What letter is it? I think it is. It's lowercase sigma. I'm going to have to check. 1.21. Yeah, that's capital sigma. Yeah, lowercase sigma is this one. I'm pretty sure. I better check.
Yeah, I'm pretty sure.
Oh, good. Sure. Been saying it for 10 years. Okay, so we're going to find. Let's just substitute in the numbers that we've found here. So we have the mean is 1.5, and we have sigma. Our standard deviation is 1.2, and less than x, less than the mean is 1.5 plus our standard deviation. And we can include the 2 ones, it's not really going to matter. And so if we evaluate those, we'll have 0.29 x and what's that going to be? 2.71. Okay, so all we've done there is break down the statement that it's asking us to evaluate. It's saying, what's the probability that the random variable lies in this region? Now, if you think of matches in a box that could be defective, it goes all the way from 0 defective matches all the way up to 50 matches. Imagine all of them being defective, right? And what we're asked here is, what's the probability that between 0.29 and 2.71 matches? So 0.29 matches is occurring here somewhere, and 2.71 is occurring here somewhere. So then the probability that we are asked to calculate is the probability of 1 or 2 matches being defective. Okay, so 2 ways we could do it. BPD for 1 plus BPD for 2, or we can just do a BCD where our lower boundary is 1, our upper boundary is 2. We have 50 trials and the probability of it being defective is 0.03. Point 0.59.
Yeah.
Excellent. Okay, so I think the tricky part with that one is just we're using the mean and standard deviation. We'll evaluate this statement, and then we have to recognize what discrete values satisfy that statement. So between 0 and 3. Very good.
Do you have to do like a statement after, or you just find that and
Let's see the question. It just says find.
it just says fun? So
Yeah, so we've found it. Yep.
that's all good.
Yep. And if it wanted you to articulate it, you would say, well, this is the probability of between 1 or 2 matches being defective. Yep. Okay, so we're on to part C then. Find the mean, standard deviation, and variance of non-defective matches. So this here is the distribution of defective matches, all right? And the distribution of non-defective matches is going to be the same, right? Except it's the inverse probability of it being non-defective, of it being effective, working, is 0.97. Okay, so the mean is going to be 50 times 0.97, which will be, what's that? 197 to 47.5, 48.5. The standard deviation is the square root of the variance. We'll do the variance first. 50 times 0.97. This is revealing something interesting. It's the same as what we had over here, isn't it? So 1.46, and that means our standard deviation will be 1.21. All right, so that's just the inverse distribution. Very good. Any questions about G3?